All right, welcome to the explainer. Have you ever just stopped and wondered, why does your shadow get shorter at noon? Or why do we even have seasons? It seems so simple, but these everyday mysteries, well, they're all part of this incredible cosmic dance between our Earth and the sun.
And really, it all kicks off with this one single idea. An idea that completely flips our perspective on its head. I mean, for basically all of human history, it was just obvious, right? The sun rises, it travels across the sky, it sets. But the truth? The reality is the total opposite. It's not the sun that's moving, it's us.
So, okay, we're on a planet that is constantly spinning. If we just accept that one single fact, what else does that unlock? What other little mysteries about our world suddenly start to make sense? Let's dive in with a really great question that came from a 12-year-old. So, our investigation really begins with this awesome puzzle from a girl named Rashmika. She's 12, and she noticed something about the coconut trees near her home. In the morning, their shadows were super long, right? But by the afternoon, they'd shrunk. And that observation led her to wonder about something, well, something really fundamental.
Which one is it, really? Is the sun actually flying across our sky? Changing the angle of its light and making shadows shrink and grow? Or is the Earth itself turning, just making it look like the sun is moving? I mean, this is a choice between two completely different ways of seeing the world. And the answer, as it turns out, is that we're the ones moving. The Earth is spinning. This daily spin, what scientists call rotation, is the first huge piece of the puzzle. And it doesn't just explain Rashmika's shadow problem. It explains why we have day and night in the first place.
Okay, to get your head around this, think about a merry-go-round. Imagine you're on it, and it's spinning, let's say, counterclockwise. Now, if you look at a tree just standing there off the ride, what happens? It looks like the tree is moving past you clockwise. But you know the tree is standing still. It's an illusion created by your own movement. That's called relative motion.
And guess what? Our planet is doing that exact same thing, just on a much, much bigger scale. It's constantly spinning, or rotating, on this imaginary line that goes right through it, called an axis. And that spin, which goes from west to east, takes about 24 hours to do one full turn. And that's it. That's the rhythm of our day and night.
You know what's just mind-blowing? This is not some new idea. We're talking more than 1,500 years ago. The brilliant Indian astronomer Aryabhata, he totally nailed it. He said our view from Earth is just like being on a boat. As you move forward, the shore looks like it's moving backward, right? Even though you're the one moving. It is the absolute perfect analogy for how we see the stars drift across the night sky to the west.
Okay, so rotation, that explains the daily motion of the sun. Check. But hold on, what about the stars at night? If we're just spinning in place like a top, shouldn't we see the same stars every single night? So why is the sky in July totally different from the sky in January? There has to be something else going on.
And there is. It's our second big movement, revolution. So while our planet is doing its daily spin, it's also on a much, much bigger journey, a year-long trip around the sun. So you've got two motions at once, the daily spin and the yearly orbit. And because we're constantly moving along that yearly path, our background view, our cosmic scenery, changes night after night.
Now, this year-long journey is also what gives us our seasons. But this is where we run into one of the biggest, most common misconceptions in all of science. Seriously, the reason we have summer and winter, it's probably not what you think it is. I mean, it seems like the most logical guess in the world, doesn't it? Of course, it's summer when the Earth is closer to the sun, and it's winter when we're farther away. That just feels like pure common sense.
But that common sense idea, it is absolutely 100% wrong. No. The distance from the sun has practically nothing to do with our seasons.
So here's the deal. The myth is all about distance. The scientific reality is all about the tilt. In fact, and get this, the Earth is actually closest to the sun in January. Yeah, right in the middle of winter for those of us in the Northern Hemisphere. The real secret to the seasons is that our planet's axis, that imaginary line it spins on, isn't straight up and down. It's tilted over.
And because of this tilt, think about what happens in June. The top half of the Earth, the Northern Hemisphere, is literally tilted towards the sun. So the sunlight hits us more directly. It's like shining a flashlight straight onto a wall instead of at an angle. The light is concentrated, and we get more hours of it. That direct, long-lasting heat is what we call summer. Then, come December, we're tilted away from the sun. The light is more spread out, the days get shorter, and that gives us winter.
Okay, let's tackle our final mystery. We're talking about the most dramatic shows our sky has to offer. You've got the sun, the earth, and the moon all in this constant celestial dance. And every now and then, they line up just perfectly, creating a shadow play on a truly epic scale. We're talking about an eclipse.
And this really is a fantastic question, because it seems impossible, right? The sun is 400 times wider than the moon. It's enormous. So how on earth can our little tiny moon completely blot it out during a total solar eclipse? It just doesn't seem to add up.
Well, you can actually figure this one out for yourself. Right now. Seriously, try this. Hold your thumb out at arm's length. Now close one eye. See? Even though your thumb is tiny, you can easily use it to completely block out something way bigger across the room, like a friend's head or a TV. The exact same thing is happening up in the sky.
This whole idea is called apparent size. And it all comes down to what has to be the most incredible coincidence in our solar system. Even though the sun is 400 times bigger than the moon, it just so happens to also be about 400 times farther away. And the result? From our unique viewpoint here on Earth, they appear to be almost the exact same size in the sky. It's just perfect.
So really, it all just boils down to a perfect cosmic lineup. For a solar eclipse, the order is sun, then moon, then Earth. The moon gets in the way and casts its shadow on us. For a lunar eclipse, the order is sun, then Earth, then moon. This time we get in the way and we cast our shadow on the moon. It's really just a question of who's blocking whose light.
So let's just put it all together. It's amazing, isn't it? A few simple movements explain pretty much everything we see in the sky. Our planet's daily rotation? That gives us day and night. Its yearly revolution around the sun? That's why the starry background changes. That crucial tilt of our axis? That's the real reason for the seasons. And eclipses? Well, that's just a stunning show of perfect alignment and apparent size.
And that just leaves us with one last thing to think about. We've seen just how incredibly important that little tilt is for, well, for everything. So what would our world be like if it wasn't there? Imagine, a planet with no seasons at all. The weather where you live would be exactly the same every single day, all year long. How would that change everything? Thanks for joining us on The Explainer.